great job. You have just invented DNSSEC. Okay, so I'm just going to walk you through what you invented. You have now invented all the major ideas in DNSSEC, a deployed thing that took several years to invent. You should be super proud of yourself. All right, so DNSSEC, the idea is we're going to sign all DNS records. It's signed, so you can check the signature, and that will let you, the recipient, verify that by verifying the signature, they verify the DNS record. And this will mean that we no longer need to worry about spoofing attacks, man-in-the-middle attacks. We don't have to trust the cache or the resolver. We don't have to worry about cache poisoning. It addresses all of those problems. The remaining challenges the DNSSEC solves, this more complicated design, is, well, it deals with the fact this is a distributed database by having this hierarchy. DNS records may change, and we didn't talk about how to deal with that, but DNS records come with a lifetime that tell you how long you should be able to cache this record for. So we're just going to include that in the information we sign. The way a query works is as the resolver starts querying the DNS root, then queries like .com, and then finally queries Google's name server. And each level, it's going to get a signed statement about the public key that's used by the next level, and then it'll use that public key to verify the response when it queries at the next level down. Okay. So the final answer, you can trust that it's right because you can verify the signature with some public key, and you know that that's the right public key because that was included in a response to a previous query, which you itself verified, and so on, recursively all the way up to the root. And the really cool thing here is because these results are signed, that means they're cacheable. They're cacheable, and they're cacheable by like the resolver. So the resolver can cache these signed records, and then if another client makes the same query, the resolver can send back those signed records to the new client, and the new client can verify each one of these signed records along the chain. And so that way the client doesn't have to trust the resolver. The client can verify everything for themselves. So the picture looks something like this. We got the resolver. The resolver is going to start by asking one of the root servers, and then we'll ask it, hey, I'm looking for the IP address for google.com. And the root server will say, I'm sorry, I don't have the answer for you, but I can refer you to someone who will get a little closer, or refer you to the name server for .com. So far, this is how ordinary DNS works. Notice that the response does not include an answer for the IP address of google.com. It just says who to ask next. Okay, so that's how ordinary DNS works. Of course, in ordinary DNS, there's no security, so a man in the middle could be modifying all of his data. Each line here is called a resource record. It's one record in DNS. You can think of DNS as a database that has a bunch of these records. So for instance, the line that says com.ns a.gtld blah, blah, blah. What is that line saying? It's saying the name server for com is a.gtldservers.net. And the next line is a record that has that A, and this is an A record, and that says the IP address of that host name is 192.5.6.30. Okay? So each line is a resource record. You can have a resource record that describes what the IP address of a host name is, or what the name server for a domain is. Responses include some set of these records. Okay, so after the resolver gets this response, it now knows it should ask the name server for .com this question. So it asks the name server for .com this question, and the answer that will come back will be, I don't know the answer, but I can tell you the name server for google.com and the IP address for that. Okay, so now the resolver will query the name server for google.com, and google.com will return the answer to the query we wanted, the IP address of www.google.com. Okay, so that's how ordinary DNS works. There's no security. Once this finishes, we've got the answer, but we've got no integrity, no assurance that any of these things are correct, that we didn't get sent astray somewhere along the path.